The objective for this video is to learn how to find the critical value for a hypothesis test for the difference between means for dependent samples. In an effort to improve the skills of 10 students, a teacher provides a weekly 1-hour tutoring session for the students. A pretest is given before the sessions and a post-test is given after. The results are shown in the table below. At alpha equal to 0.01, can it be concluded that the sessions help to improve the students' mathematical skills? Since we are comparing matched data values that correspond to specific students, these samples are dependent. There are 3 assumptions that must be met before using the t-test for 2 means when the samples are dependent. 1. The sample or samples are random. 2. The sample data are dependent. 3. When the sample size or sample sizes are less than 30, the population or populations must be normally or approximately normally distributed. Step 1 in testing the difference between means for dependent samples is to state the hypotheses and identify the claim. In order to do this, we will first need to assign one of the samples as group 1 and the other as group 2. We will assign group 1 as the pretest values and group 2 as the post-test values. If the sessions were effective, we would expect the post-test scores to be greater than the pretest scores. So if we calculate the differences with the orientation pretest score minus post-test score, then we would expect that difference to be negative. We will use the notation mu sub d for the mean of the differences in pretest and post-test scores for the population. So our null hypothesis would be that mu sub d is equal to 0. The alternative hypothesis then would be that the mean of the differences is less than 0. The claim then would be in the alternative hypothesis. Step 2 is to find the critical value. The sample consists of 10 matched pairs. The number of degrees of freedom will be the number of matched pairs minus 1. So we will have 10 minus 1, or 9 degrees of freedom. Since this is a one-tailed test, we will travel along the second row of the t-distribution table until we locate the column that contains the critical values for tests with a 0.01 level of significance. And we will find where that column intersects the row with 9 degrees of freedom. This intersection occurs at the value 2.821. Since this is a left-tail test, the critical value is negative 2.821 for alpha equal to 0.01 and 9 degrees of freedom. In this video, we learned how to find the critical value for a hypothesis test for the difference between means for dependent samples.